Okay, so for our last topic, we're just going to take a peek at linear inequalities. They work very much like linear equations for the most part, with a little added to it. Okay, so for linear inequalities, the one thing I want to point out to you before we start looking at examples is that if you have the less than or equal to sign like you see here, or the greater than or equal to sign like you see here, you're going to do a solid line when you graph the line. And we're going to graph the line just like we graphed regular lines. We're going to do y equals mx plus b. We're going to do that slope-intercept form. If you see less than or greater than just these two, then it's going to be a dotted or a dashed line. Okay? And then there's some shading that's going to occur, and so that would be the main thing that would be real different. Okay? So the idea here is you are going to start by getting the inequality into slope-intercept form. But one of the big things that you need to remember is that if you multiply or divide both sides by a negative number, you have to flip the sign. This was a rule that you did with regular inequalities as well. If you multiply or divide both sides by a negative number, you have to flip the sign. So if you take a look at the first example at the bottom of this page, they want to get this into slope-intercept form, so that means get the y by itself. You're going to start by doing a negative 2x to both sides. So this is just regular graphing. But when you get to the point where you might multiply or divide both sides by a negative number, like we just did here, now we need to flip that sign. So that less than sign is now going to become a greater than sign. So, and then I need to remember that I got to divide that, and I have to divide that. So I'm going to get a positive 2/3 x and a negative 5. So if you take a look at this graph, it starts at negative 5. So 1, 2, 3, 4, 5. Here's where it starts. And the slope is positive 2/3. So that's up 2 and over 3, up 2 and over 3. And this is a dashed line because the sign, like we see here, less than or greater than will be the dotted or dashed line. It has to have the or equal to part to be a solid line. And then the last thing is you got to figure out which side to shade. So you're going to shade either above the line or below the line. And what that means is all of the points in the shaded area are good points, and all the points that are in the non-shaded area don't work. So again, for example, on this one, we had y is greater than 2/3 x minus 5. So I need to really just pick one point, and if the origin is available, I'm going to do the origin. It has to be a point that is not on the line, because if it's on the line, that's not going to tell me which side to shade. So it's got to be on either side. I like the origin because the work is quick, so I'm going to put in the point 0, 0. 0 for the x, 0 for the y. So it's going to look like this. And I'm going to multiply, which is going to give me 0 minus 5, which is negative 5. So I just tested the origin. I just tested this point, and I got this. 0 is greater than negative 5. Is 0 greater than negative 5? Well, yes, it is. So because it is, that means I want to shade the side that the origin is on. So notice here they shaded above. Any of these points up here would work, any of them. They would work like this. I could pick any of these points. Any of the points down here, if I pick them, they're not going to work. Like, let's just try it to see. So let's see what point. So 1, 2, 3. What if we did 1, 2, 3, 1, 2, 3, 4? I think that's that point right there. I'm sorry, 3, negative 4. That would be below the line. So if I test the point 3, negative 4, so it's going to look like this. Here's the inequality. So the point 3, negative 4 is below the line. So 2/3 times 3, I'm going to multiply minus 5. And you could use your calculator for this. And then I can simplify the 3 with the 3. And that's going to give me 2 over 1, which is just 2. and 2 minus 5 is negative 3. And so they're saying negative 4 is greater than negative 3. Well, you know what? It's not. The closer you are to 0, the bigger you are. Negative 3 is actually the bigger number. So this did not work. So the side that doesn't get shaded, those points don't work. So any of these points down here you try, they're not going to work. Every point up here that you try is going to work. And that's why that side is the shaded side. All right, so let's take a look at another example. Here we've got number 1. It's ready to graph. It's in slope-intercept form. You're going to start at negative 5. You're going to go up 1 and over 3. It is a dashed line or dotted line because the sign is greater than. And then you have to decide, where you're shading. So again, I like to use the origin as long as the line's not going through the origin. So if I test the origin and it works, that means this side is shaded. If I test this origin and it doesn't work, that means I would shade down here. We could see, of course, where they shaded already, but let's take a look at what it looks like. So we've got y is greater than 1/3 x minus 5. If I test the point 0, 0, and again, I just like the origin because it's fast. So you multiply, you get 0. That's negative 5. Is 0 greater than negative 5? It is. So that means the origin is on the good side. All of these points are going to work, and you could test any of them. You could pick 17 of them right now and test them. They're all going to work, and that's why it gets shaded up here. And any of these points down here are not going to work. So you could test a bunch of points if you want, but really one point's going to do it. If I test the point and it works, shade that side. If I tested the origin right now and it didn't work, then I would be like, hey, this is the side that's not shaded, and I would shade down here. All right, let's take a look at number 2. This is ready to graph. It's in slope-intercept form. I would start at negative 1. The slope is negative 2, so I'm going to go down 2 and over 1, down 2 and over 1. It's a solid line because this is less than or equal to. It's that or equal to part that makes it solid. And then I need to figure out which side to shade. So the origin is available. It's close to the line, but it's not on the line. So if I take this equation and I test the point 0, 0, but again, I could test any point as long as it's not on the line, it would look like this. So this would be 0 minus 1, which would be negative 1. 0 is less than or equal to negative 1. Well, that is not true. 0 would be bigger than a negative number. So I just tested the origin right here. It did not work. So this has got to be the side that doesn't get shaded. These are the points that aren't working. So therefore, I know that this is the side that needs to be shaded. Now, number 3 kind of reminds you that if it's not in slope-intercept form, you need to get it that way. So move things around. Number 4 is another reminder about if you divide both sides by a negative number, you're going to have to flip the sign. That would be key on this. Okay, and then let's take a look at these last 2 because they're a little weird. They don't really follow the norm. And this is horizontal and vertical lines. So y is less than or equal to negative 4. So remember, why are you laying on the ground? It's going to be a horizontal line. It's going to be here at negative 4. And this or equal to part means it's going to be solid. Otherwise, it would have been dashed, right? And then for this one, you don't actually have to test a point. You just have to think about what this is saying. So this is saying y is less than or equal to negative 4. So when you think about that line, you're looking for the points where the y is less than or equal to negative 4. So I'm not testing things. I'm just going to try to think about what points this would be. I want the y to be less than negative 4. So that's going to be below the line. If it was greater than or equal to, I would have shaded above because the y's would be greater than negative 4. So y's that are less than negative 4 are below the line. And so you're not testing a point. You're just trying to shade what this is saying. Let's take a look at the last one. This is going to be a vertical line with the x, right? And so we have a line here at positive 7, vertical. It's dashed or dotted because it's greater than. It doesn't have the equal to part. And again, I'm not going to test, I just have to think here. X is greater than positive 7. So when I look at that line, which is actually dashed like that, I'm just thinking which points have x's that are greater than 7, and that's going to be on this side. These are points that have x's that are greater than 7. So when it comes to horizontal and vertical lines, you just graph what it's saying, and you're not testing a point for it. Remember, when it comes to inequalities, the shaded zone, all of those points work. There's lots of good answers for inequalities. And if it's a solid line, then those points also work. If it's a dashed line, those points don't work. The lines are called boundary lines because it's kind of cutting the boundary off for the answers to the non-answers.